Hello everyone. Today, I'm going to show you an incredible trick, transforming this old, rusty angle grinder, often thought of as only good for cutting and grinding, into a powerful, versatile welding tool. It's quite dirty and rusted, so my first step is to spray it thoroughly with WD-40. This helps loosen any grime and rust, making it easier to clean and allowing for a smoother disassembly process. This thorough cleaning is essential for proper functionality and to avoid any contamination during the modification. With the rust mostly gone, I'll begin disassembling the angle grinder. I'm using a screwdriver to carefully remove the screws holding the casing together. It's important to keep track of all these small parts, as we'll be reusing them later. This allows me to access the internal gears and components. With the screws removed, I gently pry off the front cover to reveal the gear assembly. Next, I'm unscrewing the back part of the casing. This lets me open up the entire body of the grinder. I carefully separate the two halves of the casing, exposing the motor and wiring inside. My next task is to remove the motor's armature, which is the rotating part of the motor. I carefully extract it from its housing. Then, I detach the remaining wires from the main body, ensuring they are all disconnected. With the armature out, I can now focus on the switch mechanism. I'm using a screwdriver to unfasten the switch from the casing, as I won't be needing it for our new project. Once the switch is attached, I'm cutting off all the existing wires connected to it and the original power cord, clearing the internal space. The next critical step is to disconnect and remove the wiring from the motor component. I'm using a screwdriver to loosen the terminal connections and then carefully snipping the wires that attach the power cord and switch to the motor. This is important because we'll be rewiring this component for its new purpose. Now I have the core motor coil, also known as a stator. It's still a bit grimy, so I'm giving it another good spray with WD-40. Cleaning this internal component is essential to ensure proper electrical contact and efficient operation once we reassemble it. I'll wipe away all the dirt and debris until the coil is visibly clean. With the coil clean, I'm now taking a piece of sandpaper to carefully sand down the terminals and contacts. This is important to ensure good electrical conductivity for the new connections. I'm meticulously scrubbing away any remaining corrosion or residue. A smooth, clean surface is crucial for a strong electrical connection. I'm taking a section of PVC pipe. I'll measure it against the stator and mark where I need to cut, as this will serve as a core for our new induction coil. Next, I'm taking black electrical tape and wrapping it securely around the PVC pipe. This insulation is vital to prevent any short circuits and protect the windings we're about to create. With the PVC pipe insulated, I'll drill a small hole into one end. This hole will be used to anchor our wire as we begin to wind the coil. This precise hole ensures a neat and secure starting point for our winding. I'm now carefully winding a red electrical wire around the insulated PVC pipe. Each turn is crucial, as this winding will create the electromagnetic field necessary for the welding process. The more precise the winding, the more efficient our new tool will be. After completing the winding, I'll drill another small hole at the end of the coil to secure the finishing wire, just as I did at the start. To ensure everything stays in place and is well insulated, I'm using hot glue to firmly secure the red coil within the stator. This prevents any movement and provides additional electrical insulation, making the assembly robust and safe. I'm now securing the entire assembly in a vise to ensure stability while I work on the connections. This precise arrangement allows for careful soldering. I'm meticulously soldering the ends of the red coil to the original terminals of a stator. This is a critical step, as it establishes the primary circuit for our welding mechanism. Next, I'm adding additional yellow wires, soldering them to different points on the coil. These additional taps are essential because they will allow for different power outputs and functions, making our tool incredibly versatile for various tasks. Each solder joint must be strong and secure for reliable performance. Finally, I'm wrapping all the solder connections with electrical tape. This is paramount for insulation and safety, protecting against any accidental short circuits or electrical shocks when the tool is in use. With the internal wiring complete, I'm ready to reassemble the angle grinder. Next, I route the wires to the main body of the grinder casing, preparing to close it up. I reattach the back casing of the angle grinder, making sure all the wires are properly aligned and no pinching occurs. Finally, I tighten the screws on the back casing to completely seal the grinder. This brings the external structure back together. I carefully thread the wires through the casing and securely fit the motor assembly back into the housing. I then close the casing, ensuring all wires are properly seated and protected. Finally, I replace the back panel and secure all the screws. This completes the transformation of our angle grinder's body into a custom power unit for our welding tool. It's exciting to see the pieces come back together. I'm disassembling an existing electrical plug to reuse its internal components. I carefully remove the screws and separate the housing to access the metal terminals. I am stripping the red and yellow wires. To make a strong and flexible connection, I will twist the stripped copper wires in preparation for connection. These ensure excellent conductivity and a secure connection. I carefully connect the stripped yellow and red wires to the terminals inside the plug, ensuring a tight and secure connection. I'm securing each wire with a screwdriver to ensure a firm, reliable connection, and then I'll snap the orange and white casings together to complete the plug assemblies. This makes the tool adaptable and safe to handle. I prepared the main wire for soldering. I stripped the insulation off the yellow wire. I'm attaching alligator clips to one set of these leads. This clip will provide quick and easy connections to various components, completing our power output system. For the actual welding torch, I'm taking a large metal clamp, often used for welding. I'll disassemble it by removing the screws, exposing the copper contacts. These contacts are key for conductivity in our new setup. I then meticulously reattach the copper contacts and secure the main red wire to the clamp. This wire will carry the current to the welding rod. This transforms the ordinary clamp into our custom portable welding torch. To prepare for the welding demonstration, I'm using an angle grinder to clean and shape these two square metal tubes. A clean surface is essential for achieving strong, reliable welds, as it removes impurities that could weaken the bond. I'll grind the edges to create a bevel, which helps the weld penetrate deeper and provides a stronger joint. I plug in the modified angle grinder, and using our homemade welding tool, I begin to weld the two pieces of metal together. I attach the alligator clips to one piece, completing the circuit. Watch closely as I touch the welding rod to the metal. See those bright sparks and the immediate heat? That's the concentrated energy in action. The metal heats up instantly, creating a strong, clean weld. Our homemade tool is incredibly powerful. The metal instantly heats up and melts, creating a strong bond between the two pieces. This DIY device proves that with little creativity and resourcefulness, you can achieve amazing things and transform old tools into powerful new instruments. Thank you for watching, and I'll see you in the next one.